Yeah, we're going to cruise through some of the good and bad science. All right, and we're good to go. So I'm going to start with SETI. We heard this a lot. Search for extraterrestrial intelligence. So one of the earliest SETI ideas came from Nikola Tesla, our dapper fellow up here, which that's something I learned putting this talk together. I didn't realize he was one of the first ones. In 1896, he had the idea that if you sort of ramped up the power in his wireless communications and pointed it in space, you might talk to Martians, and that was what he talked about. So that was where this idea of searching for extraterrestrial intelligence started. The fellow in the middle, Frank Drake, we'll hear a little more about him later. He really did the first modern SETI project back in 1960 using some radio telescopes. And then new projects were popping up in the 60s, 70s, into the 80s. And then in 1984, the SETI Institute was founded by our good friend Jill Tarter, who did the intro video, and others. And that is a nonprofit research organization that is looking for extraterrestrial intelligence, still cruising along, SETI at home, that kind of stuff all comes from the SETI Institute. So the basic idea for these SETI searches is you have a radio telescope and you can sort of point at specific things and look for signals. You can sort of just drift across the sky and look for signals. And one of the ways that modern projects use that is they sort of piggyback. So you have a radio telescope that's doing a project, that's looking at stuff around on the sky, and you have an extra little receiver on piggybacking, also looking for signals pointed at those directions. So that is a cool thing that people are doing. All right, let's get into the movie itself. So Earth's radio bubble, this is something that Jill mentioned, the opening shot where we started Earth and we start pulling back. So as we pull back through the solar system and then out into outer space, we hear older and older music and radio broadcasts. And the basic idea is there, but it gets the details really, really wrong. So when we start off right near Earth, 1997 is when this came out. If you hear the first couple of songs, they're like Spice Girls, Third Eye Blind, classic stuff in my iTunes playlist. And then as we pull further back, we hear older stuff, you know, the Dallas theme song's in there, some solid disco. You get to the moon landing, MLK's I Have a Dream speech, FDR, Hitler, et cetera, et cetera. And the details are really bad because, first off, radio waves are a kind of light wave. Light travels at the speed of light, which is fast, 670 miles an hour, but it's not infinitely fast. And farther lights are fainter. I keep saying that backwards. Farther lights are fainter. Think about a car driving away at night. The lights, as it goes away, get fainter and fainter. And so what happens is, for about 100 years, the Earth has been broadcasting TV and radio that long. That expands out into space in all directions and travels at the speed of light. So the sun is about 8 light minutes away. It takes light 8 minutes to get from the sun to the Earth. Saturn is something like 2 light hours away. And the edge of the solar system-ish, where Voyager 1 is about 13 light hours away. So the edge of the solar system is only 13 hours behind our TV. I don't even get to my DVR that fast. So talking about the Dallas theme and stuff like that out in the outer reaches of the solar system, that's old news. So that scaling is really bad. And then we start to see the Eagle Nebula, which we are wearing. And that's sort of the last few bits of radio that we hear. And the Eagle Nebula is 7,000 light years away. So we've still got quite a while for our radio waves to get out there. So they totally missed the boat on that. One last little bit here. This bubble is expanding out into space at the speed of light. And so if you pick a spot, or a star, you can see what shows they're starting to get. This plot I found online, this picture is about 5 years old, so I kind of got to shift everything out. Here's Vega that we heard about. So if you look down at this one that's shifting out, they're getting the first episodes of Seinfeld and Saved by the Bell. So that's good for them. Unfortunately, our signals, because they get fainter as they get further from Earth and it drops off with distance, by about 2 light years away from Earth, it's so faint that you wouldn't hear it above the background radio noise in the galaxy. So certainly the Vegans at 26 light years away, even if they could get these signals, it's going to be way too faint. They would never be able to see the Hitler image and send it back. Bummer.
All right, so one of the first telescopes, or the first telescope we see in the movie is this one. This is a real radio telescope. It's Arecibo, which is located in Puerto Rico. One thing that Arecibo is very famous for is the SETI program. In 1974, this telescope famously sent out this. This is the Arecibo message. This was deliberately beamed out into space towards the M13 star cluster. It might look like junk, but this was apparently very carefully thought through. What you're looking at here, from the top, these are the numbers 1 to 10. We then have the atomic numbers for some key elements, the formulae for the compounds that make up DNA, and then the squiggly thing here is the DNA double helix. We have a stick figure human, This is supposed to represent the human population and the height of a human somehow. Here we have the solar system, so we've got the sun, Earth, the third planet is raised to show where the message came from, and then this is supposed to be an image of the Arecibo dish. So, 2 reasons this is unlikely to be our first contact with aliens. First of all, if you looked at that, would you think, oh yes, this was sent by an intelligent civilization? Second of all, the star cluster it was sent to is 25,000 light years away. This signal has been traveling for about 42 years, so it has quite a long way to go before it gets there. However, in 2009, for the 35th anniversary of this message, another message containing a gene sequence was sent out to some more nearby stars. So hold tight and see if we get an answer from that one.
So they talk about a few different objects that they're looking at with radio telescopes. They talk about pulsars briefly. You can ask me later if you want to know more about that. One thing they talk about is M87, or the black hole in M87. This is a very, very big nearby galaxy, one of the biggest nearby galaxies. Nearby, I mean 50 million light years away. It's got a huge supermassive black hole in the center, much smaller than a single pixel in that image. It's swallowing a lot of gas and material. It speeds it up to almost the speed of light, gets very hot, and can actually spew out jets of radiation, and that's the sort of blue thing you see. This is a 5,000 light year long jet coming from just outside that black hole, and that thing is very bright in radio waves. So when they talk about looking at the black hole in M87 with Arecibo, that's what people do. That's great. Another thing that Ellie mentions that she has looked at in the radio is Cassiopeia A, Cass A supernova remnant in the constellation of Cassiopeia. And here is a picture of it. So this is a supernova, a star that exploded about 300 years ago. There's no record of anyone seeing it on Earth, which is a little bit weird, but we have lots of observations in the last century or so showing that this thing is an exploded star about 300 years old. This is a picture in X-rays. It is also a very strong radio source, one of the brightest radio sources in the night sky, and one of the first radio sources that astronomers looked at. So also another very accurate thing that she said, so that was good. Now we come to the first quote that we're going to talk about. We have a few quotes in here. So Evil Drumlin says, Ellie is wasting your time looking for aliens because in outer space there's nothing but noble gases and carbon compounds. Any astronomer worth their salt knows that hydrogen makes up 75% of the normal matter in the universe. That's what makes up most of the universe. So the sick burn here would be it's all just hydrogen, Ellie, but oh well. So here are the noble gases and some carbon compounds. We do actually detect those in space, in nebulae and clouds of gas and high redshift faraway galaxies and supernova, but way, way, way less amount of that than hydrogen. And in fact, you probably need these carbon compounds to get life as we know it, so you probably do need those out there to get life, which is interesting. All right, so on to the, quote, horrible innumeracy in contact, the thing that I assume keeps Jill Charter up at night when she has to talk about this movie. The quote is, Ellie says, there are over 400 billion stars out there just in our galaxy alone. True. If 1 in a million of those has planets, and 1 in a million of those has life, and 1 in a million of those has intelligent life, there would be literally millions of civilizations out there. So we can do the math and multiply that stuff together, and you get that, which is not equal to millions. So check your work, Ellie. Sorry on that one. But this sort of echoes the idea of something called the Drake equation. Here's our friend Frank Drake again. And he sort of posited this in the 60s as a calculation and as sort of a discussion of how can you calculate the number of active communicating extraterrestrial civilizations in the Milky Way, and you multiply these things together. The first one is the number of stars made per year in the Milky Way galaxy, and astronomers have a pretty good handle on that, 7 per year. The next one is the fraction of those stars that have planets. A decade ago, people might have said 20%, but since the Kepler spacecraft has been up there and we've been looking really hard for planets, we say basically about 1. We think pretty much every star has a pretty good shot at having at least a planet. Then we have the number of planets that could have life, planets or moons. So the solar system has Earth, Mars maybe under the surface, maybe a couple of moons of Jupiter or Saturn. So there's a range of maybe 1/2 to 5 typically, so let's just go with 3, sort of in the middle there. FL is the fraction of these things that actually develop life. And geologists and biologists think that it's pretty easy to get life going. Life got going pretty quick on Earth after it formed. Noted mathematician Ian Malcolm says life finds a way. So let's go with 100% of the time you get life. Now we start getting real dicey. So the fraction of life that develops intelligence, talk to your friend, neighbor, philosopher, or religious leader, maybe 10%, and then the fraction of those civilizations that actually communicate or can communicate interstellarly, maybe 10%. And then this last one, how many years does that civilization exist? We've been sending out radio signals for about 100 years. Maybe we've got another 100 years, maybe we've got 10,000 years. I'm going to be a little pessimistic and say we've probably got another 100 years before we blow ourselves up, depending on the election results in November, maybe less. But you multiply those all together and you get the number of civilizations out there, and 42, oh, Douglas Adams fans go crazy.
Right, moving on to some more astronomy that's done in the movie. We see in this flashback that Ellie is watching a meteor shower. Anyone who's ever watched a meteor shower, I recommend it if you haven't, will know that meteors are really, really bright. In fact, they showed them on screen. You do not need a telescope to observe them. Ellie has two telescopes set up here. I have no idea why. Not only do you not need a telescope, it would be extremely difficult to use one because meteors move very fast. Telescopes allow you to see a teeny, teeny, tiny fraction of the sky at a time. By the time you see a meteor, point your telescope is long gone, and you certainly won't be able to track it across the sky. However, another reason I wanted to mention this is anyone who is interested in meteors, there is actually a meteor shower coming up this week, peaking on Thursday. An example of some meteors for you. This is a stacked image, you don't see that many at once, but I recommend looking at them, they're very shiny. The one that's happening this week is called the Eta Aquarids. Meteors happen because comets come through the inner solar system, and the Earth then passes through the debris left behind by those comets. The one that's happening this week is from Comet Halley, a very famous comet. Came through a while back, and the Earth is going to pass through the debris this week. This gives rise to the Eta Aquarid meteor shower, and then 6 months later we go through the other side, and that gives us the Orionids, which was actually the picture I just showed you. So that's pretty cool. Going back to the movie, we saw another telescope. This is where the discovery actually took place. This is a real radio observatory. It's called the Karl-Jansky Very Large Array, or VLA. This is Exhibit B in my list of reasons astronomers should never be allowed to name anything. The VLA is an interferometer. This means there's lots and lots of dishes, 27 here. And apparently, if we discover alien civilizations, we get another 45 dishes. That's awesome. The way it works is all the dishes point, well, you can use subsets, but you can also point all the dishes in one direction. And then if you do that, it acts as though you've got one really, really gigantic dish, which is prohibitive to build. So this is a really cool facility. You can visit it. This is me there. I'm actually standing in one of the dishes. They don't let the general public do that, but it's cool. And you can see one of the other dishes just behind me. Interesting point, I'm squinting like mad because I forgot my sunglasses, and it's a big dish and it's bright white. It's actually really painful to be up there, but it was good fun. So this is located in Socorro, New Mexico. It's a very pretty area. It's fun to visit. They do have a cool visitor center. But do not go looking for this little canyon where Ellie likes to hang out, because that's about 250 miles away in Arizona. So we're going to be very critical of science in this movie, so I'm going to start with one thing that they did get right. The first time we see Ellie at the VLA, she's observing during the day. And a lot of people might find this odd, because don't astronomers work at night? But the radio is really cool. You can actually observe in the radio during the day. The first time I did a radio observation, it was really exciting to be told your observing shift is 10 a.m. to 4 p.m. That's so cool. The reason you can do this, which obviously you can't in the optical, is twofold. First of all, the sun is not very bright in the radio. The sun's light peaks in the optical range of the spectrum, which is, of course, why we've evolved to be able to detect optical light, because that's most of what we get. This plot here shows you across the electromagnetic spectrum, from X-ray up here down to radio, how bright the sun is, and you see the radio is way down here. The sun is still very bright though, just not as bright as in the optical. So the other thing that really helps us out is the atmosphere. In the optical, the atmosphere gets hit by light from the sun, and it then scatters it off in other directions. This is why if you look at the sky during the day, even away from the sun, the sky looks bright. The reason it looks blue is that it especially likes to scatter blue photons of light. But it doesn't scatter the radio. So if you point your radio dish directly at the sun, you're going to see the sun's very bright, but you can go just a little bit away and the night sky looks completely dark. Say the day sky even looks completely dark. So you can observe in the radio during the day. However, you do not observe at a radio telescope the way that Ellie is observing here. We see this a couple of times. She really likes to listen to her telescope on headphones. And this is a common mistake because people know they listen to the radio. But as we've said a few times, radio is just light. It's just another wavelength of the same light that we see. Light extends far in both directions away from what our eyes can see. If we go to higher energies, up here we get into ultraviolet, X-ray, gamma ray. These are all very scary things that luckily our atmosphere blocks from hitting us. If we go to the lower energy side, we get into the infrared. This is what we feel as heat. Some of that gets through the atmosphere. We get into microwave, and then we get down here into radio. So we do use radio light to encode sound to listen to on your radio, but it is not sound. You do not listen to it. Some other things that Ellie does wrong. She really should not be observing at radio facilities because she doesn't know the rules. One of the things you have to be very careful of at a radio observatory is interference. This is why they put observatories in the middle of nowhere. They want to get away from things like TV signals, cell phones. One of the things they will make you do if you visit is switch off your cell phone. They will absolutely not allow you to use a walkie-talkie. So the laptop that she's using when she's, for some reason, observing on the hood of her car is also a little bit dodgy. You can get shielding for laptops, but they are problematic. I actually heard from a colleague of mine at Jodrell Bank, an observatory in England, that laptops have recently become a real problem because it's pretty much impossible to buy one with a processor speed of less than 2 gigahertz these days. And that causes interference in exactly the range of the spectrum that people are trying to observe. Some other things that are very weird about this scene where Ellie detects her signal, not only is she screaming into an illegal walkie-talkie, she's screaming the coordinates that the telescope is already pointed at to the people in the control room who can see where the telescope is pointing. So I have no idea why she's doing that. You also see that as she's getting the signal, the dishes are moving, so they're not actually on source at the time that she gets her signal. So it's a very, very strange scene, and it gets stranger.
All right, so on to Vega, which we hear quite a bit about in the movie. So Vega is a real star. It's a very bright star, one of the brightest in the night sky in the constellation of Lyra. Here it is, Lyra the Harp. So there's the harp, there's the top. Very bright star. It is blue-whitish. It's hotter than the sun, a little bit bigger than the sun, so they got that right. They talk about how it's a blue-white kind of star. It's also a young star, and when they're talking about, oh, is this an alien signal, and when they first detect it, they say that, oh, it's only 450 million years old, and so it's too young to have life. And that's also accurate. It's about that old. When the sun was that age and the Earth was that age, about 450 million years old, that was when the first bacteria were starting to come around on Earth, so certainly not aliens that could communicate. And so they comment that maybe they're just visiting, and in fact, that is what we find out later in the movie. One issue with this, though, is she yells out the coordinates over and over, the telescopes lose, and the coordinates she yells out are actually over here. So it's not quite right. The book has the coordinates right, and there's just a flip of 1 digit. So we're thinking that there was just a little typo or miscommunication in there, so that's unfortunate. Another thing that we're going to harp on a bit is they start yelling about Lyra and Vega are about to set, and it's right on the horizon, and the sun's coming up. First of all, you see in this scene where she's hearing the signal, the dishes are pointing pretty high up. They're not near the horizon when something's about to set. So that's a problem. Also, we know that it's late October, right? They're carving pumpkins and making jokes about vampires. Later on, the government has an official statement saying that they discovered the signal at 6:30 a.m. Mountain Standard Time. And so early morning, it's sunrise-ish, that's about right. Unfortunately, from Socorro, New Mexico, in late October, Vega has set already at 2:30 in the morning. So Vega's been below the horizon for 4 hours when this happened, and that's just one of those things they could have just changed that number and it would have been totally accurate. So that's the kind of stuff that bugs me. Okay, moving on. This is one of my favorite quotes. It's obviously hydrogen times pi. Okay, what the hell does that mean? All right, well, we can unpack this a little bit. It took me a little bit to figure out what the hell they were talking about. But so hydrogen, most abundant element in the universe, a very simple atom. It has a proton, that's the blue ball here, and an electron, the red ball here. And those things spin. They spin like the Earth spins on its axis once a day. And if those spins are lined up, it stores a slight amount of energy in the hydrogen atom, and then if the electron flips over and they're misaligned spins, it releases that energy. And that energy gets released as a photon, as a kind of light, and it's the same everywhere in the universe. The wavelength of that light is about 21 centimeters, about that long, or a frequency of that number in megahertz, millions of cycles per second. So that's the hydrogen they're talking about. Pi, we know and love and remember from elementary school. Pi is the ratio of the circumference to the diameter, 3.14159, dot, 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 dot. So you multiply that frequency from the pi hydrogen spin flip, as we call it, times pi, and you get this number of megahertz, divide by 1,000 to get gigahertz, and this is the exact number that they're looking at in the movie. So they got the number right, so good for them. But that's what they meant by hydrogen times pi. They also talk about primes, a number that's divisible by only 1 in itself, and they get the first primes through 101. We see people using tick marks and using their fingers to count stuff. This is how astronomers work at 6 in the morning because we aren't that good at that point. One of my other favorite lines in the movie is "Make me a liar." Right after they get this signal, and they think it might be aliens, "Make me a liar." Book written by Carl Sagan, he wrote that line. He also had a similar line, "Extraordinary claims require extraordinary evidence." And I think this is really an overarching goal of any good scientist, is I have an interesting discovery or any discovery, and I want you to challenge me and try and pick it apart, and if it can stand up to that, then it might be real. And so Ellie asked her team to try and make her a liar. What else could this be besides a signal from aliens? Is it AWACS, so Air Force reconnaissance planes? Is it White Sands Army missile range, which is pretty close to Socorro? Here's a picture I took of White Sands testing range when I was visiting in the area. Was it the space shuttle? Was it spy satellites? They go through all these things. It wasn't any of those things. They rule it all out. It's probably aliens. All right. Then, as Vega's about to set, they say they're going to hand off to Australia. What they are almost certainly talking about is the dish. This is Parkes Observatory, Parkes Radio Observatory in Australia, made famous for observing and getting the relayed information from the Apollo 11 when it was landing on the moon in 1969, and also made famous in one of MC Heise's other favorite movies, The Dish, which is mostly about sheep, but also there's some astronomy. So, you know, handing off to another observatory as it sets in one place is totally reasonable. We do this a lot to keep tracking stuff. One problem, though, Australia, way down in the southern hemisphere, Vega, a very northern star. So Vega actually only at best skims the horizon from Parkes in Australia, and there's no way the dish could actually observe Vega, so that sucks. So sorry guys, nice try. One other thing that they refer to, which is pretty cool, is, you know, they pull up this guy in Australia and give him the coordinates and tell him to look for it on this, you know, very rudimentary version of Skype, I guess. And, you know, there's other talk later on about, you know, telling everyone and sending out telegrams all over the world about this discovery. And this is something astronomers do. This is something that I've done quite a bit of. So this is, you know, me. I wrote this, we do call them telegrams, you know, telegram. I wrote this in 2008. My team was on the Keck Observatory in Hawaii. I took an observation of this exploded star, this supernova, and we were the first humans to realize it had helium and a little bit of hydrogen, probably came from a star about 20 times the mass of the sun. We throw this out there into the universe, and every astronomer on the planet can take a look, and if they think it's interesting, follow it up, help us check it out, etc.
So in addition to the very rudimentary Skype, a lot of the things that they show on the computer screens are not really what you have on your computer screens in an observatory. Although if you notice the scene where they're rushing around pressing buttons on all the computers that have gone to sleep, that's real. At 3 in the morning, you kind of doze off and realize all your computers have gone to screensaver and you're not paying attention. However, the screen they're looking at here, that looks fairly realistic. It's a one-dimensional spectrum. This is something that we take a lot. Here's an example of a one-dimensional spectrum of a galaxy. This is ARC 220, a starburst galaxy. So this is the kind of data they're looking at, and you can get a lot of information out of this, like what kind of elements and compounds are in the object you're looking at. So here we see some carbon monoxide, some water, and so on. One thing you cannot do by looking at a one-dimensional spectrum is immediately go, ah, that's an encoded television signal, which is what they apparently do here. They're looking at that, and Ellie immediately says, get me a TV monitor. So that's magic, as far as I can tell. So in our introduction video, Jill Tarter mentioned a scene where it seems like Matthew McConaughey was trying out for Interstellar. What she was talking about was a scene where he's talking to Ellie, and he says that assuming she travels at a significant fraction of the speed of light, she will come back only 4 years older, whereas over 50 years will have passed on Earth. So this is under the assumption that the machine was going to be some kind of sublight travel machine. And what he's referring to is, of course, special relativity. So this is the idea posited by Einstein in 1905, that if you travel very, very quickly, you age more slowly. And the very, very simple way of thinking about this is to imagine that you always travel at exactly the same speed, call it the speed of light. If you stand completely stationary in space, you are moving with that speed through time. If you start moving very, very quickly through space, you're taking some of that speed away from your time direction. So you move more slowly through time. Now, most of the time we don't notice this effect because any motion we have is way, way, way less than the speed of light. But if you do start moving very close to the speed of light, you will find that you move through time more slowly, so you age more slowly. So this is the famous twin paradox, which is actually not a paradox at all. And it would have been true had this been how the machine worked. It's weirdly specific numbers, though. To say that the 50 years passing on Earth is assuming you're traveling very close to the speed of light, 26 light years there, 26 light years back, so it's going to take you at least 52 years. The 4 years that pass from Ellie's point of view is, I crunched the numbers, and it's based on traveling at 99.7% of the speed of light. So given that obviously no one had any idea how the machine worked at this point, I have no idea where he got those numbers from. But the principle was kind of right. And of course, they went into a lot more detail about that in Interstellar, the only bit of science they got right in that movie. So let's talk more about the machine. We heard that this ended up costing over $500 billion, which is quite a scary amount of money, even in 1997, especially in 1997. If you convert that to 2015 money, that would have been more like $740 billion. So that's kind of ridiculous. Just for fun, we pulled up the entire budget of the US for 2015. And you can see the Defense Department over here. This was only $583 billion, only, she says. So I'm filing meeting aliens under things we could do if only we as a species decided to stop bombing each other. So another thing we see in the movie is the Mir Space Station, where apparently Haddon is hanging out in his last few days. This was a real Russian-run space station that operated from 1986 to 2001. This is what it looked like. It was the first modular space station, was built in orbit between 1986 and 1996, exactly like the Starship Enterprise, according to the original series, not the reboot, which is wrong. So Mir held the record for the longest continuous human presence in space until 2010, when it was surpassed by the ISS. So far so good. The point where the movie went off the rails was Haddon saying the reason he's there is because the low oxygen environment is keeping him alive. And the atmosphere on Mir was very deliberately kept at pretty much exactly the same as Earth, so I'm not sure where he got that low oxygen from. So when Ellie goes off in the machine, we see her go into a wormhole. She later refers to this in the hearing as an EinsteinRosen Bridge. That's one of these. The only way I think any reasonable person can picture how this works is just to imagine for a moment that space is two-dimensional. So space is like a piece of paper. You want to connect 2 points on opposite ends of the piece of paper. So you just fold it over and bring those 2 points close together, and now you can hop between them really quickly. So now try and convert that into three-dimensional space being folded over on itself, and good luck with that. So this is kind of what she was talking about, and this is why she was able to travel 26 light years plus wherever it was that the fancy beach was in 18 hours. So moving on right to the end of the movie, this asshole here tries to convince everyone that the signal could have been a hoax. Theoretically, sure, but this would have been really, really hard, and I find it kind of disappointing that Ellie goes along with it. And the reason for that is he posits that this could be generated from a satellite in orbit. And the problem with this is that the Earth is moving a lot. It spins around on its axis and it moves around the sun, whereas the stars from our point of view, are kind of stationary. So there is no conceivable orbit you could put a satellite in that would leave it at the same position relative to the background stars all the time. Unless possibly the star was at 0 declination, that might work, but this one isn't. It's way up in the north. There is no way you can do that. So it's kind of disappointing, as I said, that Ellie ends up conceding that this is plausible.
All right, so before we finish up here, we just want to remind everyone of our next event 2 weeks from tonight, AoTATX 19 at 7:30 p.m. We're going to hear from newly minted doctoral candidate, Rachael Martinez, about wobbling stars and actually looking for planets around other stars. We're going to hear from Bill Wren of the McDonald Observatory, talking about preserving our dark skies, both out here and in West Texas. And then Dr. Dave Pooley of Trinity University is going to tell us about the astronomy in Hamlet.
All right, so we just want to finish by saying a huge thank you to the Alamo Drafthouse for hosting this event, to Odell Brewing Company, the official beer of AoTATX, our fantastic Star Party Queen, who has been videoing this for us, and of course you, the audience, for coming out and enjoying this with us. Thank you very much.
We'll be outside hanging out and drinking.